Welcome to the second in this series of MiniMeds. This year it's Mini Epidemiology. I know you learned a lot about what epidemiology is and the word, and each week you learn a little bit more about this really wonderful and fascinating and really important discipline in a faculty of medicine, including, of course, ours. My name is Abe Fuchs. I'm proud to be a member of this faculty, and I'll be your host tonight. So let's start with first, because this is epidemiology, with some demographic data. How many of you are university students? Okay. How many of you are CJEP students? That's great. High school? Wonderful. That's great. An informal count tells me that we have more high school students than CJEP or university, which is fantastic. So tell all your friends, we want you to come here for the lectures. There's special prices just for you, so we can have you here. We also want you to learn about our medical school and our university, so we can encourage you to be students here, so you too can be like our volunteers and wear these fancy red t-shirts, which we'll hear about in a few minutes. Second, housekeeping. You have to register every time you come in and get your materials so we can keep track that you've been here. You can get special points for attending all the lectures and a diploma at the end. But also, you'll have a chance to pick up the card on which you can inscribe your questions. At the end of the lecture or during the lecture, quietly write down any question you may have. And then at the end of the lecture, I'll give you more instructions where we'll collect the questions and I'll read them to our speaker and he'll answer them, but we can try and organize it. So just remember to write down any questions you have. No question is too small, no question is too difficult, and there are no stupid questions. So write down anything that intrigues you and we'll deal with that at the end. Second or third, as you know, at the Mini-Epi website, there will be questions to the speaker. And for our speaker of last week, Professor Hanley, the questions will be up and the answers this coming week. So make sure you check. And also remember, and I'll remind you at the end, we'll have a special question and a quiz, I think, or a mystery from Dr. Hanley at the end. But before we get to the end, let's get to the beginning. And that is going to be what I think will be a wonderful lecture. It's often the case that when you think, and we think about epidemiology, we think about infectious diseases, right? That was one of the early events in the history of epidemiology. So we tend to think of epidemics, because the words are related. So we think of infections, whether it's typhoid or cholera or Ebola. But in fact, epidemiology is a lot more than that. And you'll hear tonight one of the really fascinating questions has to do with what to me is a wonderful series of issues. When you take the phenomenon as natural as pregnancy and childbirth, conceiving, carrying, and bearing children, and nurturing children, the most natural of acts, certainly not an illness, and something that is very much part of nature, and of course part of nurture too, because after birth, and perhaps even before birth, nurture, the mother's, the parents' behavior is important. What's really interesting over the last 25, 30 years is how the most natural of acts and nature and nurture now interfaces with technology. And that's an interesting dilemma and an interesting benefit. And again, epidemiology, like many disciplines in medicine, is a sense of cost-benefit. What do you gain? What do you lose? At what risk? And the question now for us will be, and we'll learn about it tonight, whether we look at all those interventions, some of them wonderful, like in vitro fertilization, or infant formulas, or cesarean sections, all of them in their own way technologic, interfacing and bringing both benefits and costs and risks, and we'll learn about that tonight. And our guide this evening will be a very important and senior faculty member in the Department of Epidemiology and Biostatistics and Occupational Health, and also a member of the Department of Pediatrics, Dr. Michael Kramer. Dr. Kramer brings to this field an enormously diverse skill set, both as a clinician. He practiced at the Children's Hospital for many, many years doing pediatrics in a clinic in the emergency room, and also was one of the founding figures in a field that we now call clinical epidemiology, in one sense taking the data, the ideas, the concepts we learn about by studying populations and apply them to specific individuals in the clinic, in the hospital, between one doctor and his or her patient. And the question is always, how do we apply all these data sets? And that's part of what clinical epidemiology is about. And Dr. Kramer published a book on that many, many years ago that became an important textbook in the field. That was only one of almost 20 books that he's edited and co-authored, 350 publications, which is very impressive. But he's also provided not only publications, but tremendous leadership in the field of epidemiology, not only in Canada, but really throughout the world. He was a member of many expert committees at the Institute of Medicine, a very prestigious organization in the United States. And here in Canada is not only a James McGill professor at McGill, which is a very high honor for selected faculty members at the university, and not just the Faculty of Medicine, but he also provided very important leadership as the Institute director, first the chair of the advisory board, and then the director of the Institute of Child and, I want to get the title right, it's Human Development and Child and Youth Health, which is one of the 13, I think it was, institutes of the Canadian Institutes of Health Research. He's received many accolades, membership in the Royal Society of Canada, was president of Societies of Pediatric Research, and continues very important work, again, on child nurturing, nutrition, maternal health, all of it at a very important international level. He just came back from Belarus and is leaving soon for some other faraway land. But we're delighted that he landed here tonight and will tell us all about fewer babies, older mothers, lots of interventions, where are we, and what are our prospects. Dr. Kramer.
Thank you very much, Abe. That was a very kind and generous introduction. In his usual way, Abe Fuchs didn't say that he is a former dean here for a couple of terms. And, don't you? Okay, sorry. And you can see from the tenor of that introduction why he was so successful as a dean. So we miss you, Abe. So I am going to talk today about the changing landscape of childbirth. And what I'm going to focus on in terms of what's changing, maternal age, which Abe mentioned, changes in fertility and treatments for infertility. Those I'm sure you're aware of. Some of the other things maybe less so. What's happening with preterm birth, babies who are born too soon, and early term birth, babies who are born just a little bit too soon. What's the role of obstetric interventions, particularly induction of labor and pre-labor caesarean sections in those changes in the occurrence of preterm and early term birth. And then I'm going to conclude with, because I've spent about the last 20 years heavily involved in surveillance, perinatal surveillance for Canada, using both national vital statistics and hospitalizations and other databases that essentially portray the picture in Canada over the last 20 years or longer. We've learned a lot about doing perinatal surveillance in Canada, but I want to show you 3 of the crises that we faced in the course of doing that perinatal surveillance, and showing how data can often be misused as well as used, and how that gets picked up by the media. And some of these crises you may be already aware of. So it's not surprise to any of you that births to teenage mothers have decreased. Most of that decrease, these are data from 1995 to the most recent data we have is from 2010. And you can see there was a big drop. The green line here represents the live births per 1,000 women or girls 18 or 19 years of age. That's come down almost in half. Most of that decrease occurred between 1995 and 2004 or 5. It's been pretty stable since then. The red line in the middle are less frequent, and those are younger teenagers between 15 and 17 years, but the same trend. Births to girls, 10 to 14, are very, very rare and have remained rare in Canada. So the bottom line here is a reduction in the rate of live births to teenage mothers of all ages. Probably my guess is, since we cannot break this down into immigrants and non-immigrants, that one of the reasons that the red line and the green line have flattened out in the last 5 or 6 years is because the decrease in fertility or live births to teenage mothers in Native Canadian, when I say Native Canadian, I mean women or girls born in Canada, has been counterbalanced by people coming from other cultures where birth during teenage years doesn't have the same stigma or perhaps not even the same adverse health effects as it does in the Canadian-born population. But the big change, of course, has been at the other end of the childbearing age spectrum, that is births to older mothers. And the yellow line here, for the same exact years as I showed you for teenage pregnancies, shows you the trend which has close to doubled over this and continues to go up. This one is not flattened out between 1995 and 2010. The yellow line is 35 to 39-year-old women, which, of course, pregnancies in that age group have, as I said, almost doubled over that time period. But those are much more frequent than those to even older women either 40 to 44, shown by the red line, where the rate has doubled over this 15-year period. It's still rare for women above the age of 45. Although they get a lot of newspaper headlines, they're still relatively uncommon in terms of the births in the population and the rate among women in that age group. Very few of them have live births. So this kind of picture that you see in newspapers and magazines and things like that is more common than it used to be. But this woman, I don't know what her age is. And this was a picture off the internet, but this still remains a rare phenomenon and almost certainly required some kind of obstetrical technology. Some of the techniques that Abe talked about before, and that I'll mention more as we go along. Now, this graph here, which shows the contrasting trends in fertility with age, which of course drops precipitously. The fertility is shown here on the left-hand side and y-axis, which drops by 90% between age 20 and 45. And conversely, the rate of spontaneous abortion or miscarriage, which goes up, has gone up about tenfold over the same time period, shown here on the right-sided axis. And what that shows is that one of the major reasons for women not being able to produce live births is the fact that they lose them more readily, rather than that the egg doesn't get fertilized, although there's problems with fertilization as well. But keeping a pregnancy, becoming pregnant in the first place, but then keeping a pregnancy becomes much, much more difficult as the age approaches 40 and particularly 45. Now, to just change gears for a moment, looking at the total fertility rate, which is the number of children per woman, these have changed radically also in recent times. These are data for the whole world for 2013. And the light blue and light green colors represent anywhere from 0 to 2 children. And won't be surprising to you that Canada has a very low rate, that Western Europe has a low rate, and that China has a low rate, and that Australia has a low rate. But there's a few surprises in here. For example, places like Brazil and Chile have very, very low fertility rates as well. And some of these rates, particularly in Europe, Japan, and even Canada, are insufficient to maintain the population, so that the only reason that the population is going up in countries like Canada, and the same is true in most European countries, is because of immigration. And that people tend to come from parts of the world where the fertility rates are higher. And at least for some time, maintain the fertility practices or the cultural practices in terms of having more children that they had in the countries from which they came, but with a tendency over time to become acculturated and adopt more of the, particularly with women in the workforce and how much it costs to have children in daycare in most provinces, et cetera, that the number of children becomes an economic as well as issue of self-fulfillment. So this is the only place in the world where there's still high fertility rates consistently is sub-Saharan Africa, and that remains the case. So I'd like to shift gears from talking about fertility and infertility to talking about preterm birth. And this is a picture of a very preterm baby, probably around 26, 27, 28 weeks, attached to all kinds of ventilating machines and IVs and an umbilical line and so forth. And these babies are surviving more than they used to survive, but they're not becoming more frequent. On the other hand, overall preterm births, and I'm going to show you the breakdown in a few minutes, have increased a lot in the 1980s and 1990s. So this is the overall preterm birth rate, which the WHO defines as a birth weight before 37 completed weeks, and normal pregnancy goes on for 40 weeks. Increased a lot between the mid-1980s from around 6 or 6.5%, peaked in around 2004 at around 8%, and has shown a decline since then. We'll try to understand why this has occurred in a few minutes. It's also easy to get these kind of data from our neighbor to the south, so, and it's very important when considering American data to look at whites and blacks separately, because particularly for preterm birth, but for some other pregnancy outcomes as well, the rates in blacks are much, much higher. So the trend for preterm birth over a slightly more than 30-year period in the U.S. Started at about 8%, which interestingly is what it was in Canada at its peak. There are a number of reasons for that we can go into if you're interested afterwards. And the U.S. Rate peaked a couple of years after ours in 2006, and it too has been coming down, and it's been coming down since 2006 in blacks as well. So this disparity, at least between the red line for blacks and the green line for whites, hasn't really budged much in the last 10 years or so. But it certainly decreased over the 1980s and 1990s, when it was more than twofold higher in blacks than it was in whites. Now, within preterm births, all births less than 37 weeks are not the same. And the increase that I'm showing, that I just showed you on the graphs for both Canada and the U.S., are a combination of different groups of gestational ages. So all of these babies are less than 37 weeks. But if you look at the trends in the very preterm births, the one like that I showed you in Life magazine, the ones that are less than 27 completed weeks, or between 28 and 31 completed weeks, have been flat. Those are the two lines on the bottom, the pink one and the blue one. They haven't budged in the 16-year period in which this study was covered in its publication. Where the increase has occurred is what we call late preterm births. So the 36-week babies and the 32 to 35-week babies. These late preterm or moderate preterm births are the ones that have increased, and we'll try to understand a bit why. Well, one of the reasons is because of an increase in twin births, and the purple line on top and the light blue line on the bottom represent the U.S. and Canada twin rates over about a 20-year period between the early 90s and 2010. And there was a slightly higher twinning rate in U.S. Canada has pretty much caught up. The overall increase over this period has been about 1%. So it's in the early 90s, it was about 2% in Canada, almost 2.5% in the U.S. And it's in both countries, it's increased by about 1%. So about half of preterm babies, about half of twins are born preterm, that is less than 37 weeks. So if the overall preterm, the overall twinning rate has gone up by 1%, that has increased 0.5% to the overall increase in preterm rate, in which we said it went up from 6 to 8 in Canada, from around 8 to 10 or so in the U.S. So about 1/4 of the total increase in the preterm rate in both the U.S. and Canada is probably attributable to the increased birth of twins. So if I asked you why are twin births increasing, what would you say? Okay, what kind of fertility? Okay, so I expected you all would say was IVF, and that's only part of the story, and perhaps not the major part of the story. So these are data that were published a little over a year ago in the New England Journal, based on a registry of IVF from the U.S. And if you look at the observed rate of twinning, it's gone up between 1971, so this is a 40-year span now on the x-axis, between 1971 and 2011. Most of the increase has been since the mid-'80s. Part of that increase, maybe a third of the increase, is just due to the changing in the age distribution of the childbearing population. So the twinning rate is just partly due, the increase in the twinning rate is partly due to the fact that fewer younger mothers are getting pregnant and more older mothers are getting pregnant, and older women are at higher risk for delivering twins and higher order multiple births. And if you look at, if you look at the proportion as a percent of all the twins, so these add up to 100%, the proportion that are due to younger women who were having most of the babies earlier on in 1971, those less than 30 years, has actually gone down by about half. Whereas the proportion of twins born to women above 30 or above, has increased in all of these age groups, 30 to 34, 35 to 39, and 40 years or more. So that now only about half of the twins are born to women under 30, and the other half are born to women 30 or more, and still only a small fraction born to women above the age of 4. So part of the reason that there are more twins is that women have postponed their childbearing until later on in life. In terms of how they conceive, this is twins again. In the late 90s, almost 80% of twins were conceived via natural conception, and only about 20%, a little more than 20%, were medically assisted conception. And now it's more like 2/3, 1/3, or 60-40, but it's still natural conception is responsible for more than half, even in the most recent data of all twins, not medically assisted conception. That may surprise you. And that's because there's a lot of young women who are getting pregnant, and a lot of them are having naturally conceived twins, even though the rate of twinning is much higher among those older women who are getting some of this medical assistance. And it may also surprise, so that may be a surprise to you, that most twins are naturally conceived. It may also surprise you to see that non-IVF, among the medically assisted conceptions, non-IVF treatments are just as common, if not more common. It's the IVF is catching up. And these are infertility hormone drugs that are either given orally or by injection, and that cause the mother to ovulate, and often ovulate with more than one egg, which gets fertilized, and then there are twins or even higher order multiples that are born. So these non-IVF treatments still are responsible for a higher percentage of the twins than IVF. So IVF is an important part of the story. Certainly its increase is doubled in terms of the proportion of twins that are due to IVF, but it's not the major contributor. Among IVF births, things have changed as well. So again, we have these data on IVF since the late 90s, not all the way back to 1971, because they didn't have it then, and it wasn't a registry. But you can see that singleton births, that is one birth, it has increased considerably over that 14-year period. Twin births have been about the same, but what's really dropped is triplet and higher order pregnancies, which is a good news, because these babies are all premature, and some of them are very premature. And so survival rates when you get into the triplets and quadruplets starts to fall dramatically. And it's not surprising to understand what's happening with the Singletons, twins, and higher order multiples when you see what's happened with the number of embryos implanted in IVF. In the early, in 1997, the vast majority of IVF cycles were treated with 3 or more embryos, figuring that this is an expensive, invasive process, and we should put in a lot of embryos. Hopefully they won't all survive, and then we'll deal with them if they do. That practice has, as you can see, has dropped precipitously by about 2/3. There has been an increase in 2 embryo transplants, implantations, figuring that twins are not such a disaster, as half of them are born preterm and most of them survive. But now there's an increasing emphasis, and particularly here in Quebec, since the new law, which obligates, if you want to get free IVF, you can only have 1 embryo implanted, and that's a law that's been in Sweden for quite some time as well. And that reduces, of course, the higher order multiples are eliminated, and the twins are eliminated as well. And so there's less preterm births among the IVF infants. But of course, the success rate isn't as high as it is with when you implant 2 embryos. So just to go back, what we said about preterm birth, why we saw that maybe a quarter of the increase in preterm birth that we've observed in Canada and the U.S. and many, many other countries, about a quarter of it could be explained by twins. And now we're leaving with the infertility story and twins and higher order multiples. Let's get back to preterm birth. And why, if I asked you to guess, why do you think preterm birth is increasing among singletons? I heard somebody say here, because of the older mothers. Did somebody say that over here? That does contribute, because older women are actually at higher risk than teenage girls are for preterm birth. But there's another reason, and I suspect you may not be aware of this. So these are data taken from the U.S. between 1995 and 2005. And based on the U.S. birth certificate, which has a lot more information than we have on our birth certificates in Canada, they can be roughly, and I say roughly, subdivided into these 3 categories, which have been very popular in the preterm birth epidemiology literature. The top line, the open circles here, and you can see that the rate of these has been entirely flat, is due to spontaneous preterm labor. So probably about half of all preterm births are initiated by the mother having contractions and preterm labor, and then the membranes rupture and so forth. The bottom line, which also hasn't changed very much, is preterm, pre-labor rupture of membranes. That's where the membranes rupture first. It's not clear whether that's the causes of that or the consequences of that are any different than they are when labor starts. And sometimes it's hard to tell which happened first, because the mother feels a contraction, and when by the time she comes to the hospital, her membranes are ruptured. It's not clear which happened first. That also hasn't gone up. What's the only thing that's gone up, this is for singleton births and preterm births, is what are called here iatrogenic. That is doctor-initiated preterm births. And we'll go into more detail about what that's about. I mentioned this earlier, one of the major trends that have occurred, these are data from the U.S., and they're a little higher than we have in Canada, but not much, is labor induction. If you induce labor before 37 weeks, there's a good chance that labor within a day or most 2 days is going to result in a birth. So if you do that before 37 weeks, you're pretty much guaranteed that you're going to have a preterm birth. The orange line here is for all races, and you can see it's still going up. It's in around 24% in the latest year of this study, which is 2008. The rate is highest, probably because of their access to obstetricians and access to health care in general among the whites. The non-Hispanic blacks are next, and the Hispanics have the lowest rate, but all of the races have been going up except the whites, which have leveled off in the last few years of this study. But they've leveled off at a rate that's about 28%, which is quite high. That means more than a quarter of the births overall are born after a labor induction rather than anything spontaneous, either the membranes rupturing or the spontaneous onset of labor. And these are rates of inductions and cesarean deliveries among these late preterm births between 34 and 36 weeks over a 16-year period in the United States. And as I said, if you do, the induction rate has doubled over this 16-year period from less than 10% to almost 20%. And if you do an induction between 34 and 36 weeks, you're going to have a preterm delivery for sure. Now, some of these, if they weren't induced, might have gone on to have a preterm delivery if they were left alone, but most of them would have probably gotten to 37 weeks or more. The cesareans are more problematic, at least in the older version of the U.S. birth certificate, because you can't tell whether the cesarean was done during labor, that is, in labor that was either induced or spontaneous, or whether the cesarean preceded the onset of labor, and it was actually done with the intention of ending the pregnancy. And nor can we say anything about whether that intention was because of indications, clinical indications in the mother, or because of convenience on the part of the mother or the doctor. But I think my guess is that unlike the situation in Brazil, where there are certain areas where 80 or 90% of the deliveries occur by elective pre-labor cesarean section, that phenomenon is still pretty rare. It's not rare in the sense of a rare disease, but it's nothing like 80 or 90%. It's a small fraction of all the cesareans, we presume. Now, I've called Singleton preterm birth a socially contagious disease, and I'm going to try to convince you of why I call it that just by showing you this map of the U.S., where there are three different colors here, with the darker color being the highest rates and the lightest color being the lowest rates. This is from 2009, but I think the map would be very, very similar today. The rates might be slightly lower because since 2006 the rates have been declining in the U.S. But it's very interesting to see these regional differences, strong differences in the rates of preterm birth, as much as 2% difference between the high rate states and the low rate states. Now, some of this you can attribute. Here in the South, there are large black populations in places like the Carolinas and Georgia, Mississippi, Alabama. But that becomes less obvious with states like Florida, Texas, and Oklahoma, which don't have very large proportions of black, and states like Nevada and Arizona, which have almost no blacks. So there's something, and then places like the Pacific Northwest, California, the Northern Midwest, and New England have very, very low rates. And some of these the middle states here, which have high black populations, places like Pennsylvania, Ohio, Michigan, Illinois, which have very, very large cities and a large black population, have much lower rates than they do in the Southeast or Nevada and Arizona. So this suggests that local practice of obstetricians as to whether they particularly induce but maybe pre-labor cesarean, people tend to not want to be too out of line with what other obstetricians in their city or state or region are doing. And if you're not doing more than the guy or the lady down the hall or in the same office or in another office in the city or delivering at the same hospital, then you must be okay. So they tend to, these practice patterns tend to be somewhat similar regionally and within cities and states. And when you get out of those areas, they are often quite different. And we've actually shown that these differences in rates among states correlates with changes over time. That changes in induction rates among states correlates quite closely with the changes in preterm birth rates over the same time period. We talk about preterm births, and I've talked a lot about preterm births up to now, but I want to also talk about what are called early term births. So are all births 37 weeks or more, which is a definition, quite an arbitrary definition of what a term birth is by WHO, are they all the same? So we studied, again, non-Hispanic white singletons in the U.S. just over this 11-year period between 1992 and 2003, and I think it's remarkable what happens and what this says about obstetric intervention over a 11-year period. So I'm going to show you each one of these lines separately. The black line are deliveries or live births that occurred at exactly 40 completed weeks. That is between 40 weeks and 0 days and 40 weeks and 6 days. Once it's 7 days beyond 40 weeks, it's now 41 weeks. So this is 40 weeks, completed weeks, which in 1992 were about twice as common as 39-week gestations. It's only a week difference. But look what happened over the 11 years. They actually switched places. They crossed. So that by 2003, 39-week gestations outnumbered, or the higher percentage of all births, than the 40-week gestations. The next two lines are births at 41 weeks, which is the dark blue line, and the light purple line at 38 weeks. So they were about the same rate, about 14% each in 1992. And by 2003, 11 years later, the 38 weeks gestations were twice as common as the 41-week gestations. Finally, the 37, which are shown by the brown triangles, and the reddish-brown squares are the 42 weeks and more, started at about the same rate in 1992 and ended up going in opposite directions, such that they were 5 or 6 times more common to be born at 37 completed weeks than they were at 42 or more weeks. So these are within the term range, or at least term and post-term. These are remarkable changes over a very, very short period of time. They say, well, so what? What difference does it make if you're born at 37 weeks or 39 weeks or 41 weeks? These are data which were taken from a study we published over a six-year period in the U.S., again, non-Hispanic white singleton births, where the reference group here is the one you don't see, which is 40 weeks. And it shows the relative risk, if you will, of dying, so this is death either in the newborn period, shown on the top part of this graph, or the post-neonatal period, which means between 1 month and a year, compared to the risk at 40 weeks. So 39 and 41, there wasn't much difference. It was not statistically significantly different, essentially the same as at 40 weeks. But at 38 weeks, you had about a 20% higher risk of dying in the first month, and an 80% higher risk of dying if you were born at 37 weeks. Even in the post-neonatal period, that is between 1 month and a year, the babies born at 38 weeks, and particularly those born at 37 weeks, the relative risks were not as high as they were in the first month, but between 1 month and a year, the risks were significantly elevated, even at 38 weeks, and certainly quite a bit so at 37 weeks. So this shift between later term births, babies from 39 and on, to the shift towards 37, 38 weeks, which has accompanied the increase in the late preterm births between 34 and 36, may have adverse consequences. There's a price to pay for that. The absolute risk in terms of an individual baby dying is very, very low. We're talking about rates of, a couple at most per 1,000. So the chances that any one mother with a baby born at 37 or 38 weeks that baby would die either in the first month or the first year is still quite low in an absolute sense, but they're 50% or even 80% higher, depending on which period of time you're talking about, than they would be if you were born at 39 to 41 weeks. Dr. Fuchs mentioned the study we're carrying out in Belarus, which is restricted to term births, that is 37 weeks and more. And this wasn't the purpose of the study. It was a study relating breastfeeding intervention to, in this case, IQ. But because we had the gestational ages, we had a large sample size of, there were about 14,000 kids who were tested at age 6.5. You could see similar kinds of effects as I just showed you for mortality. The mean IQ at 39, 40, and 41 are pretty similar and not statistically different from one another. They go down a little bit at 38 weeks, and again, these are not huge differences, 1 point, 2 points of IQ, but they're highly statistically significant. These big drops here at 42 and 43 weeks are very small samples. Very few babies make it to 42 and 43 weeks in Belarus or anywhere else anymore, as you saw. And so those are not statistically significant and may not be real. So I'm going to just shift for a moment. I'm going to talk to you about the perinatal surveillance activity that I said I've been involved in for 20 years. And I'm going to show you 3 separate public health crises that have arisen as a result of this tracking of trends over time in perinatal outcomes. And the message here is don't believe everything you read. So shortly after we started, and we started in 1995, In 1990s, it always takes a couple of years before Stats can get all the data out, and we find out about the infant mortality and the preterm birth rate, and that's why all the graphs that I show you ended about 2011, 2010, 2012. So this is a low birth weight rate, which means that the proportion of babies who are born less than 5.5 pounds or 2,500 grams. Those are about virtually equivalent. And you can see there wasn't much change either in Canada, which is shown here in green, or in Ontario, which was had a little lower rate than the Canadian rate overall for low birth weight, until starting in 1992, there was a sharp increase in 93 and again in 94, particularly in Ontario. And as it turned out, this increase in Canada just reflected the fact that about a third of the births that occur in Canada are from Ontario. So that's obviously going to affect the Canadian rate, but the other two-thirds don't affect. So this article appeared in the Globe and Mail. Everybody's familiar with the Globe and Mail. It wasn't the first page, but it was first section, A6. March 14, 1996. This is when the 1994 low birth rates were published by Statistics Canada. And being a newspaper from Toronto, of course, they like to call themselves a national newspaper, and it says national news here, but they focused on the problem in Toronto first. More Toronto newborns underweight, figures show. And for those of you who can't read the subtitle, it says, rise in number of babies with low birth weight attributed to mother's stress, poverty, and poor nutrition. So I'll show you this is what it is in text, and I'm going to show you the data in a moment. So the low birth rate increased between 1992 and 1994 in Toronto. It also increased in the rest of Ontario. I didn't show you the separate data for Toronto, but it did not increase at all in the rest of Canada. So the hypothesized causes in the Globe and Mail article was that something related to this was a time of economic hardship, the early 90s, throughout Canada, and so particularly in the urban areas, the hypothesis was that stress, poverty, and poor nutrition were responsible, and but we thought that it might be due to something else, in particular a data error. So here's the distribution of birth weight in grams in 1992 for Ontario. Looks like a nice bell-shaped normal distribution. And you see these peaks here, but those peaks have to do with the fact that a lot of these birth weights were measured in pounds and ounces, and they were rounded off to at most half or quarter ounces rather than individual number of grams. So that's why you see these peaks. But the overall shape of the distribution is fine. In 1994, you get a sense of an overall nice bell-shaped curve, but you have these weird peaks that are much too infrequent and much too precise to be due to rounding. And they occurred at these unusual birth weights like 2,749 grams and 3,203 grams. When we graph this in ounces, and we compare the 1992 distribution shown in green with the 1994 distribution shown in white, it was very revealing because these were a specific whole number of ounces. So this was 81 ounces is 16 ounces in a pound. That's 5 pounds and 1 ounce. 65 ounces is 4 pounds and 1 ounce. 97 ounces is 6 pounds and 1 ounce. This is 7 pounds and 1 ounce, 8 pounds and 1 ounce. It's very strange. Why? So it's not rounding to get this at 1 ounce. And here is a kind of just going up to 128 ounces. This really shows the whole thing. What we saw was at 5 pounds 1 ounce, there was an increase, big increase, but then these high 5 pounds and near closer to 6 pounds, there was a deficit in 1994 relative to 1992. Same thing with 6. Up here in the high 6s, there was a deficit in 1994 versus what we saw in 1992. And the same thing at 7 pounds and so forth. And what happened was when we looked into it, was there had been in 1992 two slots in the computer file for so you had number of pounds and then you had number of ounces. There was only one column available for number of ounces. So they truncated the number of ounces. So everything from 5 pounds 10 ounces to 5 pound 15 ounces became 5 pounds 1 ounce. And the same thing for 6 pound 10 ounces and so forth. So just this increase of all these babies that weighed between 5 pound 10 ounces and 5 pounds 15 ounces, which are not low birth weight because they're above 5.5 pounds, for 5 pounds 8 ounces, are now classified as being 5 pounds 1 ounce, and that was entirely responsible for the increase in low birth weight in Ontario. So this started the low birth weight epidemic, which was in Ontario, which was a public health crisis, and people, economic causes and nutritional causes, turned out not to be an epidemic, but a data error. And then it became a public relations crisis because they didn't want anybody to publish this, and they were embarrassed, and so forth and so on. So the second example was not a data error, but when you look further into the data, there was an explanation that was far less worrisome than initially appeared. So between 2001 and 2002, there was a spike, small spike, but a spike in the infant mortality rate for the country. So and it was particularly marked in Alberta. It went up from 5.6 to 7.3 per thousand. And as you saw as you can see here, between 2000 and 2001, it went down. This is a big change in infant mortality. It's not because of small numbers. In Canada, the infant mortality rate is 5.3 in 2000, 5.2 in 2001, and then also went up, not by the same degree, but went up to 5.4. Again, given the fact that we have about 400,000 births in Canada, these rates of infant mortality are not just due to statistical fluctuation due to small sample size. This is a real increase. And if you just count the number of deaths, it's quite a few extra deaths. As you can see, there's about 23 more deaths here. There's about 70 more deaths here. So these are it's a fair number of babies. When we looked at, we had a suspicion from previous work that we had done that this was a registration phenomenon, and that particularly babies near the borderline of viability, and here we're talking either about a birth weight less than 500 grams or a gestational age less than 24 completed weeks, where the vast majority, almost 100% of babies die at those birth weights and gestational ages. These are rates per 10,000 births, and you could see there was a huge jump of about 50% in these small babies, whether characterized by their birth weight or their gestational age in Alberta, and a substantial rise, but not as big a rise, in Canada as a whole. And we attributed this increase, which was not due to a data error, but due to terminations of pregnancy, some of which, and the terminations of pregnancy are usually carried out because of congenital anomalies that are diagnosed prenatally. The obstetricians like to do those terminations before 20 weeks, and they don't have to be registered at 20 weeks. When they do them at 20 weeks or later, they have to be registered as either stillbirths or live births. Now, a lot of them will be stillbirths, but some of them are born with initial signs of life, move, have heartbeats and respirations and so forth, but then die within hours or at most a couple of days thereafter. So a lot of these terminations of pregnancy that did end up as live births at these very low birth weights or very low gestational ages were dying. And they were a substantial fraction of the deaths, even though they're a tiny, tiny, tiny fraction of the births, because virtually all of them die. So instead of worrying again about poverty and malnutrition and other social causes, this was probably almost certainly a manifestation of a change in medical practice, prenatal diagnosis and termination in pregnancy, where the termination occurred a little later than everybody would like, but that ended up having to be registered because of the laws for registration in the provinces and in Canada. I'm going to just switch gears for a moment and talk a little bit about what these tiny births and the registration differences among countries. This graph, which comes from a BMJ article in 2012, graphs on the y-axis the neonatal mortality rate, that is the death rate in the first month of life, as a function of the proportion of live births less than 500 grams, here expressed per 10,000 births. And you can see that Canada, and particularly the U.S., have very, very high rates of births under 500 grams. And one could say, well, they have that's really their birth rate at less than 500 grams. Or in the U.S. in particular, with the baby doe legislation and the anti-abortion movement, it's very, very hard not to declare these babies as live births. And you can get into big, big trouble in the U.S. if you ignore and don't register these live births. Canada also has, probably because of our proximity to our southern neighbor, also not as high as the United States, but higher than any of the other countries that were examined in this study. And there's a pretty good correlation between the proportion of births that are registered less than 500 grams and the infant mortality rate in those countries. There is variation. We have the Nordic countries here, Sweden and Norway and Finland and Scotland, who have even lower than the line. They have very, very low rates of live births less than 500 grams, but even lower than you'd expect from the average of these countries. Sorry, I keep hitting this, in terms of their neonatal mortality rates. Now, WHO actually says for international comparisons, you shouldn't even use less than 500 grams, because in some countries there's a substantial mortality between 500 and 1,000 grams. So the WHO recommends comparing countries' infant mortality rates for those babies of 1,000 grams or more. So this, and you've heard, or many of you have probably heard about Canada's poor ranking among the OECD countries in its infant mortality. I showed you on the previous slide how that may be related to which babies get registered. But the actual ranking here is shown by the blue line. And you can see Canada here is certainly towards the bottom of the pile, and the US is even lower. And the only countries that are even lower, or that in terms of having higher neonatal mortality rates, are Poland, Latvia, and Lithuania. So we don't do well internationally on the ranking, but as soon as you exclude these small babies less than 1,000 grams, Canada and the US, which is where these dips occur, have infant mortality rates that approximate those in Germany, Ireland, and Austria, suggesting that it's registration of these very small and immature babies that is different among the countries, and that's responsible for a good part of the Canada and the US's in particular poor showing internationally in terms of how we compare to our, particularly our European neighbors. So the last crisis that I'm going to tell you about concerns stillbirths. And these data are from 2000 to 2009 in Canada, and you could see an increase of about 1 per thousand, from about 6 to 7 per thousand between 2000 and 2009 in Canada. I don't know how they got hold of the data so soon, but this also made it into the Globe and Mail. This one is dated August 27, 2009. Stillbirths on the rise in Canada. Now, there's one paragraph in here, I've magnified it here. You may not be able to read this because it's a little blurry, but I'm going to read this to you because I love this. This is really the misuse of epidemiology. So, in greatest danger are women with additional risk factors, including those with a previous history of stillbirth, those more than 40 years of age, or those with chronic hypertension or type 1 diabetes. Their pregnancies are practically guaranteed to end in stillbirth. Well, if you look back at the rates here, we're talking about 6 per thousand. Even if one of those factors increased the risk tenfold, which I don't think it does, you'd have 60 or 70 per thousand, which is about 6 or 7%. So you could say, actually, that those women are almost guaranteed not to have a stillbirth. But this is our national newspaper. So I'm using this as examples for you to be wary when you read these things about national, international rankings, epidemics of low birth weight, stillbirths on the rise, or whatever. Anyway, one of my colleagues, Cass Joseph, who was a PhD student in our department many years ago, who's now working in British Columbia, found exactly the same trend in British Columbia over an equivalent similar. The absolute rates here are higher, but they had an increase from around 8 to 10 in their stillbirth rate per thousand. And when you analyze those stillbirth rates in British Columbia, you could see by gestational age that the green line, which represents the early part of this period between 2000 and 2010, had much lower rates of stillbirth between 20 and 24 weeks than the more recent period. So all of the increase in stillbirths in British Columbia between 2000 and 2010 appeared to be in this 20 to 24, this borderline viability, range of gestational age. And in British Columbia, one of the things they have very, very good data on whether these pregnancies, whether they be they live births or stillbirths, are the results of termination of pregnancy, or TOP. And you could see that all of the increase between 2000 and 2002 versus 2008, 2010 was in the termination of pregnancy stillbirth between 20 and 24 weeks, whereas if in the spontaneous or non-termination of pregnancy stillbirths, there was absolutely no change at any gestational age between those 2 years. Again, suggesting that these were due to terminations at these very, very early gestational ages. And the data I'll show you on the next slide not only suggest, but actually more or less demonstrate that these termination of pregnancies for congenital anomalies are responsible for the increase. And that's true whether there was a 50% rise over this time in congenital anomaly terminations per 100, whether expressed per 100 congenital anomalies or per 1,000 total births. So some of these terminations are ending in stillbirth, some of the terminations a few are ending in live birth. Canada is one of the few countries that doesn't have a separate registration document for termination of pregnancies. I'm not saying which is good and which is bad, but that counts against our stillbirths and it counts against our live births, and it makes us look bad internationally with our stillbirths and with our infant mortality rates. So, and that's just a function of the rules and regulations for registration, not saying anything about the health of mothers, fetuses, or babies in these countries. So just to summarize, and I think we can stop. The landscape has changed, and if there are things that you're interested in knowing about, whether they're changed or not, that I haven't covered, please ask. Or are there any of the things I have shown you that you want further information on or have some opinions about, please ask. So fewer teen births, that's probably a good thing. More births to older mothers. There's some benefits and risks to that. Declining fertility rates, primarily due to the births to older mothers, and some deliberate decline in fertility across the world with women using contraception, as you saw from the international fertility rates that I showed you. More multiple births, we think we understand the reason for those. More late preterm and early term births, probably, almost certainly due to increased obstetric intervention, certainly increased induction of labor, and probably to some degree, but harder to get a handle on, due to elective cesarean sections, sometimes for indications, but perhaps not always strong indications. And finally, when you read about these kinds of infant mortality, stillbirths, congenital anomalies, and so forth, and you see them in the Globe and Mail in particular, take them with a grain of salt. And thank you very much.
All right, Michael, thank you very much. If I could have the lights, Maestro. Please write down your questions. I'm sure you have lots of them because there's a lot of issues buried in these data sets, and all of them important for public health and for the health of persons, not just the public. And the trick is, write down your question on a card. When you have a card filled out, raise your hand with the card in it, and a red-shirted volunteer will swoop down and pick it up. And then they bring them all to me, and I screen them. Now, the reason I screen them is if they're too difficult, I'm just joking.
It's the light.
Sometimes if they are personal questions, we really don't use those, like I have a neighbor who. But sometimes the real reason is simply there are repetitive questions, and we group them, and it's easier to handle more questions in the half hour that we have. So any that you want, send them down. Thank you very much. So let's start with an interesting one that is really an epidemiologic demographic question. Why are fertility rates different amongst different races? Good question. So you have your own mic.
Yes, I do.
So
I'm your mic, and this is mine.
there you go. That was a joke.
That was a joke.
Now, I want to compete. I want to beat my neighbor, where is he, Mr. Maitland, when he heard Dr. Kramer's criticism of the Globe and Mail, he said simply, think if it had been the Gazette. But
so we honestly don't know why different races have different twinning rates. It was the twinning rates question, right? Fertility. Fertility rates. It's not clear so the answer is still we don't know, but I think we know more about that than we do about presumably there are racial differences that have some genetic basis in twinning and multiples. But in terms of births per woman, most of the changes over time and the differences among countries are not based on race, but they're based on poverty, fashion, whether women are in the workforce, and there tend to be social reasons rather than genetic reasons. And these have changed within countries over time, and the ranking of fertility has, religion plays a big role in that. Look at most of the people of my age and higher from Quebec come from families of 6, 10, 12. I don't think their race has changed, but they're now having families that are as small or smaller than they are elsewhere in North America. So the loss of power of the Catholic Church has been one of these social factors, and the loss of the power of the Catholic Church has had very, very different effects in the religious Jewish communities, the religious Muslim communities, and so fertility rates are affected by whether women are in the workplace, their role in society, by the costs of bringing up children, by religious convictions, so many, and these are much, much stronger factors than anything genetic, as far as we know. Which is not to say that there aren't genes that are associated with differences in fertility, but I don't think very many of those genes have been identified, and I'm quite sure that those genes, if they have a role, are small potatoes compared to the social, religious, and cultural factors that I mentioned.
There's a technical question. What does IDF stands for? That's the Israeli Defense Force. I think you meant
IVF.
I think you meant IVF.
Oh, sorry, yes. I just assumed everybody knew what IVF is. It's in vitro fertilization. It's where women are stimulated to ovulate, that the fertilization takes place outside the womb, outside the vagina, where the sperm of the donor or the husband are matched with the ova that are harvested from the woman's ovaries. They're fertilized in a petri dish and kept for a couple of days, and then one, hopefully, or two at most, of these best-looking embryos, when they look at them in the microscope, are then transplanted into the woman's fallopian tube, in uterus, for implantation.
Some of you might want to know what Dr. Kramer meant by best looking. He really means exactly that. The people who work in infertility look at the embryos with a stereo microscope and see if their morphology, if they look good physically, and those are the ones that are selected. Okay, on to a very intriguing question. Does being born to an older mother affect fertility in the children?
Very good question. Yeah. I'm not sure it's been studied. I would think that there would be an association, if for no other reason, that kids who grow up with mothers who had children late in life would probably be more likely to have children late in life themselves, but be as a biological effect rather than a social one. I'm not aware of. It's a great question. I've never seen a study on it.
There's a really intriguing question, certainly from one of the students, who wants to know the following. For babies born at 37 weeks gestation or less, what are the causes of death? In other words, those higher risks of death within a month or a year or longer. What do you attribute that to? So
in the very preterm babies, the one I showed you on the Life magazine cover, attached to the respirator and the umbilical lines and so forth, those babies die primarily because of severe lung disease or for hemorrhage in the brain. But some of them also die from infection. Some of them get a very severe gastrointestinal disease. that gives them a severe systemic infection, or that result in surgery and taking out a large part of the gastrointestinal tract. And once they get over the acute, let's say the first few weeks or months of life, they also continue to run higher risks of death because of residual lung disease, and they also have higher rates of sudden infant death syndrome, which is a post-neonatal mortality that occurs mostly between 1 and 6 or 8 months. So they're at risk from a variety of sources, but most of them are due to the immaturity of the lungs and the brain and the immune system at birth.
You showed some really intriguing IQ data, and is it known why IQ is lower at those infants that are born at time other than the natural, like pre-38 or after 40?
So all good questions. No one has done a randomized experiment to take babies where the pregnancy is going normally and delivering them at 37 weeks. Doesn't mean that there aren't some healthy pregnancies that are delivered at 36 or 37 or 38 weeks. There are. Some of them are convenience at the mother's request. Some may be convenience on the obstetrician's request. But oftentimes those early pregnancies, whether they occur spontaneously or because the doctor induces or does a cesarean delivery, are because the mother there's something wrong with the pregnancy. And so what we don't know is whether those lower IQs or the higher mortality rates that I show you in those 37 and 38-week babies are due to the actual delivery at those gestational ages, or the reason for the delivery, whether that delivery is spontaneous or caused by the doctor. And so until we do a randomized experiment, we really won't know that for sure, but a lot of, as you saw from the changes that occurred in an 11-year period, the huge increase in the occurrence of these babies, which seem to be paralleled by these inductions, even if they had an indication, the fact that there were so many of them. If these were normal pregnancies that would have gone on to a perfectly normal 40-week delivery, I would expect that would dilute the adverse effects of the babies who were being born, let's say, on their own at 37, 38 weeks. So it's probably a mixture. We don't know for sure, but it should give us pause that there may be a price to pay when these babies are delivered early, unless there's a very, very strong indication in terms of the mother's health or the fetus's health.
So that really leads to this one. Given what you've shown, why indeed are pregnancies induced at 36 weeks? Why does that happen?
Okay. I think, first of all, it varies with the country. If you don't want to go through labor, let's say you're a Brazilian woman and you're convinced that you're, I don't mean to lean too heavily on the Brazilians because it's a wonderful country in many ways, but there is this kind of actress cult business that not wanting to go through the pain of labor and not wanting to perhaps have some sexual difficulties for the months following the delivery, of delivering by elective cesarean section. Now, in order to be sure of delivering by elective cesarean section, you can't necessarily wait to 38 weeks. So some of them happen at 39, some at 38, some at 37, and convenience in terms of when their maternity leave is, when their obstetrician's going on holiday, when their mothers or mothers-in-law can come in to help out. All these things can affect the timing. And because the absolute risk of something going wrong is low, even though the relative risk is high, I think these are felt to be unfairly felt to be kind of risk-free kind of procedures. But the more we find out, particularly from cesareans, which have a risk for the mother herself, these early deliveries may come with a cost. So on the other hand, I think in North America, where it's not 90%, where it's more like 25 or 30%, but there's some Scandinavian countries where it's 10 or 15%, and they have lower infant mortality, lower preterm birth rates than we do. You could argue, well, those are the Scandinavians. They're bigger, they're healthy, or something. The society's different. They have less stress, less poverty, and less undernutrition. But they're not as quick to do inductions or cesareans, and they're more into letting nature chart its own course, and they don't seem to be paying a price for it, and that must be because they're less interventive even among women with indications. So a woman who has high blood pressure during pregnancy or gestational diabetes, diabetes that's brought on by pregnancy, are more likely to be delivered early. A baby who's being followed with ultrasound, who's not growing as well as the obstetrician would like, is more likely to be delivered early because they're afraid that that baby's going to be a stillbirth. If the mother reports that the baby's maybe not moving as much, they may do an early delivery again to avoid a stillbirth. So in North America, I would say, in Canada in particular, most of these inductions or cesareans that are done before 37 weeks are not done frivolously. They're done for indications, but that doesn't necessarily mean that the benefits of doing them early exceed the harms, and we don't really know the answer to that.
I mean, it really speaks to the wonderful point you made about some things that appear to be biologic are really social. Mm-hmm. And it's the behavior of doctors and mothers and an unholy alliance between them. Mm-hmm. And C-section rates are now, as you said, even here, 25 or 30%, and a generation ago they were 10 or 11%.
Exactly.
Here's a question that is non-induction. How does do external stimuli for mothers affect the time of birth of a baby? If it does.
I don't think we know much about that. There are all kinds of myths about listening to classical music or going out and having a Chinese meal, and they can affect the time of delivery, but I don't know that any of them have been subject to rigorous analysis.
Dr. Kramer always wants a randomized trial. So, the trial on Chinese food you can sign up for. Yeah. You get free dinners in the last 4 weeks. And we randomize cuisines. Okay.
I'll give you one anecdote, and it is personal, but it's my kid. Our third child. I mean, normally it's the first child that tends to go on post-term, and where it takes a while. Ours was the third. It was the lazy one, and my wife was doing Chinese food, was out playing tennis. This was at 41 weeks, doing everything she could except standing on her head, which in her condition would have been very difficult. But nothing worked.
The reason I love that story is it shows once again that even distinguished epidemiologists love anecdotes, right? All my colleagues in the audience appreciate the humor here. I think it's beautiful. So, are there data about differential rates of cesarean sections in Canada across provinces?
Probably. They don't vary widely. They tend to be, they're a lot higher in the south than they are in the north. They're a lot higher in the cities than they are in the small towns and villages. And that's just because there are some GPs or family doctors who do cesareans, particularly in remote areas, but midwives don't do them, and most GPs or family doctors don't do them. So you need access to obstetricians, and those tend to be concentrated in the cities. I'm not sure, I'm not aware of any, that doesn't mean there aren't any, I'm just not aware, I don't recall any data about any east-west or Ontario versus Quebec major differences once you take the urban-rural and access to obstetricians issue into account.
Another technical question, and it's important for epidemiologists and obstetricians and mothers. How do you determine gestational age, and how accurate is it when you collect data?
Great question. And I think that question is the key to why, nobody asked this question, but I'll answer that one first because it's the same answer, why the U.S. rates, even among whites, are for preterm birth. I mentioned at the beginning of the 80s that they had 8%, which is the rate we had at our peak in 2004. And that's because the official U.S. rates for preterm birth are based on the last menstrual period. And that means that it assumes that ovulation and conception occur on the same day, which they don't. In general, ovulation probably occurs on the 16th or 17th day. So if you use, if you date pregnancies by the time of conception, which ultrasound does, rather than the date of the last menstrual period, you're going to get a couple of days. And a couple of days can mean a big difference in the rate of births less than 37 weeks, a difference in gestational age. The other thing about the U.S. is that because of the healthcare system, or lack thereof in the U.S., a lot of women, particularly poor women, and particularly black poor women don't have the same access to health care. So they either come in and have their baby without any prenatal care, and so they don't, you're asking them to remember when the first day of their last menstrual period is 9 months after that occurred, and so there are errors in the recall of when that occurred. And then there's some other biological explanations in bleeding and so forth. So the best method for estimating gestational age is ultrasound in the first half of pregnancy, and it's usually done by measuring the length of the baby, either the leg or the whole baby in the first trimester, the first 13 weeks, and then the biparietal diameter, the distance across the head in this dimension in the second trimester, the second 13 weeks, and that seems to provide better gestational ages. So one of the reasons that the rate in the U.S. is higher than in any other developed country is because they still rely, for their official statistics, on the gestational age based on the last menstrual period.
There's another technical question, interesting one. You showed a slide about method of conception and the twin births chart. Shouldn't the percentages in each method add up to 100%?
They do, but there were two, if it's the same slide as I think you're referring to, two of them were subsets of the medical conception, or the medically assisted conception. There was the spontaneous conception, and there was the medical conception, and the IVF and the non-IVF treatments were subsets of the medical. So the medical and the non-medical added up to 100, but then the other two added up to the to the medical one.
This is a young statistician in the room, for sure. We asked about races, so we've had that one before. One person wants to know if there's this law of implanting only one fertilized embryo or fertilized egg through IVF. How is it possible for a woman to have multiple children, and some of them are indeed, quintuplets?
Because those did not arise via single embryo transplantation. Those arose. They can arise spontaneously for a woman who ovulates or is given ovulation stimulants. That's not natural, but if she releases 5 eggs and 4 of them get fertilized and 4 embryos form and 4 of them get implanted, she could have quadruplets spontaneously. But nowadays, most of the very higher order multiples are due to IVF. And if you put in 5 embryos, you may hope for 2, but there's a chance you're going to get 3 or 4 or even 5. So it's usually, and if you put in a single embryo, you pretty much cannot get more than one birth.
Might get twins.
If it splits? Yeah, it's pretty unusual.
Okay, so here's an interesting sociological question and biologic. So, is the age of 35 the cutoff as the best time for having children? In other words, should one have a child before 35, after 35, and does that play a role?
Yeah, it's a great question, and it's got a very complicated answer, and I'm walking on thin ice here because there are many things that have to be counterbalanced. The article that they circulated for this course suggested that there are benefits. I would say that those benefits are anecdotal, but probably real. They're not well studied. What are the benefits of psychological for the mother, perhaps for the child, of having a mother who is satisfied in her career, is going to work, is more mature, has better financial means? What are the advantages to a child growing up in a family where the mother feels like she's doing what she wants to do rather than that she's forced to take care of the child, where there are fewer children so that more money is spent on each child, as opposed to the old days, if you will, where there were 5, 6, 8, 10 kids in a family, and the mother stayed home and didn't work. So, it's very, very hard to study. No one's going to do a randomized trial of number of kids or age at conception. So I think it's very, very hard to study. The women who are having, I'm not sure we're better off than we were 30 years ago, because it is a bit of a stretch for many women to try to be super moms and super in their career, and it does fall unfairly on the women. And so it can be more stressful despite the increased income and the fact that the mother is doing what it wants. So, and it probably varies according to the woman and the child and the father and his involvement. So that's a bit of a cop-out of a question, but I don't think we really know overall, and it's probably advantageous for some and disadvantageous for others.
I don't think it's a cop-out. I think it's a lovely example of how health issues and biology intersect with sociology, with culture, with technology, with choices, with movements in our culture, like feminist movements and self-help and so on. And it really shows you how understanding all these issues does require not only the right questions, but the methodology of the epidemiologists to answer them. So, Michael, thank you so much.
My pleasure.
For a wonderful review. And we're stopping the question period now, not because there aren't more questions. I apologize to those, but don't run yet, because we have the special mystery quiz from my colleague, Dr. Hanley, also known as the Irish leprechaun epidemiologist, who has a quiz for us. James.
Last week, we had one bookmark for Dr. Kramer, which was to do with the Vienna General Hospital and what was killing the 10% of the women giving birth at that place. Today, this bookmark is a little more obscure, but I will connect it to his talk at the end. So what you have here is a set of data on a particular incident, or I'm not going to say too much what it is, but we have a collection of people here, some of whom, about 2/3 of them who died, and 1/3 who lived. Now, if you know right away what the answer is here as to what this occasion was, or what killed these people, please don't blurt it out and spoil the fun for everybody else. Okay, so keep it to yourself for a little while anyway. Okay, we need to go through this slowly. First, you need to understand what the data are like, but there's about 2,200 people in this data set. Something happened that killed some of them. You have 3 variables altogether. You have the first variable is which social class they are, and then you have a second variable whether they were children or adults, and the third variable is whether they were male or female. And the number inside of each box, in the dotted lines inside each box, this rectangle is how many people there were. And on the left-hand side of each diagram is how many of them died. And on the right-hand side of the black bar is how many lived or survived. Is that clear? Sorry, on the right-hand side is dying, and on the left-hand side is survived. Isn't that right? Did I say it right? Yeah, now I'm saying it right. So the challenge is to figure out what this was. Was it some epidemic? Was it, what did we say today? We rehearsed this with the students earlier. Dave, what is the other name you gave it? You had another good name at the time for it. It might be an earthquake, a mining disaster, a natural disaster, a mining disaster, earthquake, act of God, storm. What on earth was this? If you know it right away, please don't spoil it for the others, though. So we need to kind of puzzle this out a little bit. And I will take questions as to what it might be, what the technical issues, and do you have any questions about the layout of the thing? Yeah? Yes? Not this century. Not even this last half century. It's older than that. Dr. Fuchs, do you know?
Well, you have to clarify the data set.
Yeah. So, yeah.
Just for everybody, you're saying here,
On the right-hand side.
many adult males.
Yeah,
right?
yeah.
And these gentlemen
Died.
died.
And the ones on the left,
survived.
yeah, and it's a fraction. Think of it as a fraction. Yeah.
So the proportion of adult males dying was.
Yeah. There was 100.
And of those, the rates of loss were very high in lower and middle economic, and were not as high in the upper. Is that right? Is that summarized correctly?
Yeah.
Yeah.
There are not a lot of children.
So children
The people today in the class were asking, how come there are no data here? There are no people in this cell. So what do you think that's actually relevant? So why might that be? No, this happened very quickly. This happened quite quickly. It wasn't over 30 years of starvation or a famine. It was not a famine or anything like that took 30 years to kill everybody or whatever. So there was no children because there was no fathers or mothers. No. So, London fog? Did it kill that many? This is 2/3 died and 1/3 of the population. I'll call them a population, although it's a strange population. Our collection of 2,200 people did not die. So, the upper, middle, and lower are pretty well. We decided today it's a matter of money, right? They were much richer on the left-hand side. The people on the right-hand side under other, somebody said, are they working? And I said, absolutely. They're an occupational group. Yeah. And in fact, the people on the left, 3 columns, none of them were working while this was going on. All right, somebody are getting closer now.
This was a disaster.
This was a disaster. Right. Please, careful now.
I won't say anything more.
Do you get it, though?
I got it.
Yeah, he thinks he got it. Okay. He was the dean. He should have gotten it. Okay? Did people at the back hear that? No, okay, let them work at it more then. The front have gotten an answer here that they whispered it, which was good. Yeah. Please, on the back, a few more as to what's going on.
You have to ask questions.
Yeah. That's right. So I'll give you more details as to when. Yeah. The leading question was when in between 1910 and 1920. Huh? It was before the war. Yes, all right, now. Yeah. Somebody asked me, where did it happen? Was it in England?
The geographic question.
Yeah. Very tricky. I would say half of the people on this population were actually European, and maybe a little less were North American. There were some from Montreal. It's a very diverse population. Aha! Titanic.
Let's have the lights. Thank you. You can now pass an epi exam without equations. So, can I have the lights, please? Again, a very special thank you to Professor Kramer. Michael, thank you for a wonderful evening. Please check the website on McGill.ca and go to MiniMed, questions, answers, lots of entertainment. Remember to get your friends to come here next week and the following weeks. Every week is interesting and different. And thank you to the students in the red shirts for helping out, who are all volunteers. All McGill Med students, many of them, who are now going home to study. And safe travel to everyone. Thank you for being here.